You hanging in there? You doing okay? Some of us are going to struggle through this. It's okay. I watch people struggle like crazy at the beginning of these courses, and some of us just start off strong and fast, and they're like, this stuff's simple. I've seen both ways people be highly successful. Probably the best student I had last semester, or top student, at least scores at the end, started off very shaky. She worked her ass off. But yeah, she didn't gain a lot of the concepts until about after exam 1, and then she was unstoppable. So give yourself a break if some of this is like going over your head. Just keep grinding at it. All right. Let's move into it. So I still got the same thing. There's all our rules. So let's just keep thinking. Sine goes with y. Cosine goes with x. Sine goes with y. Cosine goes with x. We just say we take our y value, we divide it by the radius, and that's sine. Cosine, we take the x value, we divide it by the radius. That's cosine. And then we can go get tangent and cotangent, all the other bullshit. No problem. No problem. Just by knowing our trig, there are different ideas with trig. No, let's move into this. So I've created 4 scenarios. All the same values, though. We're going to look at these. We're going to look at these 4 points. 4 different points, and we're going to see what we're going to get for sine, cosine, and tangent of them. All right, and just see how they're tied together. What's up? So let's draw our first one. Let's go into our top one. Now, where do you want to put it? So the x is small, so kind of do one of these. Wow. So let's jump in. We're like, all right, so it must be 5. It's got to be 12. 5, 12. So now the game is you got to go get that radius. You got to know what the r is. What's awesome for us is we're always going to get the same radius here. So the radius is equal to the square root of x squared plus y squared. That's what we learned from up there. We're like, all right, well, our x is 5, so it's 5 squared plus 12 squared. The radius is equal to 25 plus 144. That's equal to 169. And the square root of 169 is equal to 13. So what we call a 5, 12, 13 triangle. So if you were to drop it down like this and go 5, 12, 13, that's what the triangle would look like. But, it's not a triangle, right? We're talking about a radius. It's something very different. So now we have our radius, and we have our x's and our y's from right here. We're like, sine. Sine's just our y value over the radius. Cool. Cosine. It's just the x value. 5 over the radius. And then remember that game with tangent? It's just the numerators. Sine over cosine. 12 over 5. Or y over x. Tangent is y over x. Like slope. That'll come back later. You don't have to fill your brain with it, though. Good. Yay. Found sine, cosine, and tangent. We can go get the other ones if we wanted to. All right. Nothing too important. No big deal. Let's go to our next. Let's go over here. We got -5, 12. Okay. Just draw something up here. Negative. Here's -5. The height is 12. So if we're to go, we're like, well, gotta go get that that radius, right? X squared plus y squared. Well, what happens when you square shit? It turns freaking positive. It's the same length. It's the damn radius. It doesn't matter where you put the thing. It's always going to have it. If you still have it, 5 and 12, it's the same radius. We're going to have it being at the square root of 169 or equaling to 13 again. So our radius is equal to 13. And now our x value. Our x value is -5 and our y value is 12. So when we go to do our sine, we're like, sine is the y value over the radius. So it has the same value. Neat. Cosine is the x value, so we have to put in the negative. Oh shit. It looks like cosine might be negative whenever we're over in the second quadrant. Now let's go to tangent, and tangent is just going to be, it's just going to be 12 over negative 5. Those two values right there, or the y value over the x value, 12 over negative 5. So there's that solution, 12 over negative 5. And hey, let's have the conversation now. See 12 over negative 5? Yeah, that doesn't have to be there. That could be up here. But you're like, but the x is negative. It doesn't matter. It doesn't make any freaking difference. It doesn't matter if the negative's up top, down below, out front. It makes no difference. Makes no difference. Get used to that. Cool. So we got our answers. It looks like we got the same values as we got when we were in the first quadrant, right? When we were in the first quadrant, we got 12 over 13, 5 over 13, and 12 over 5, but everything was positive. Now it looks like only sine is positive when we're in the second quadrant. Cosine and tangent look like those are going to be negative. Anytime you have a negative x value, well shit, it's going to create a negative in one of them because of the radius we always keep positive. All right, cool. Let's go down to quadrant 3. Let's make this one. Negative 5, negative 12. So maybe it's right there. So the y value is negative. The x value is negative. Like, think about if you made a triangle right here, huh? We just call it negative 5, negative 12, and this is going to be 13. That's the game. That's the game. But it's not a triangle, right? We're just talking about radius, and it's just, this is these new rules that we're learning that we're going to get ready for. The radius is still equal to 13. I'm not going to show this again. Come on, it's equal to 13. It's 5 and 12. We're in a square, but now they're both negative. Who gives a shit? I think I even wrote up the radius wrong back there. I did. Ha! I wrote in the negative 12. It didn't make any freaking difference. Have you been screaming about that? Going, shit, that was... Yeah, it didn't make any difference though, huh? So the radius is still equal to 13. All right, thanks. Y. Dope. So let's look at our sine goes with y, so we get negative 12 over our 13. Cool. Cosine goes with x, so we get negative 5 over 13. And then we get tangent. Negative 12 over negative 5. Negative 12 over negative 5. Two negatives create a positive. So it looks like only tangent is positive when we're down in the third quadrant. Looks like both sine and cosine are negative. Huh. Well, isn't x negative in the third quadrant? Isn't y negative in the third quadrant? Strange how both sine and cosine would be negative, since sine goes with y and cosine goes with x. Now moving to our next. Now we're going to go into the fourth quadrant where we have positive x's and negative y's. Can you figure out what's going to be positive and what's going to be negative? We make our point, we're like 5 over, let's go 12 down, or negative 12 down. There's that point. Play connect the dots. Dude. Radius is 13, right? We got our x, we got our y. Let's go. Sine is going to be your y value over your radius. So negative 12 over that 13. Cosine is the x value over the radius, 5 over 13. And then lastly but not leastly, we're going to go into tangent, which is going to be your y over your x, which is negative 12 over 5. Or just think that it's the numerator is negative 12 over 5 of sine and cosine. So let's look. What have we found out? What have we gone through in our journeys? They've kind of given us something with numbers we can see. Let's make up some rules. This is the acronym. This is what you got to know. Get it down. ASTC. ASTC. This is saying, now, when we're saying this, we're only talking about sine, cosine, and tangent. We're only talking about these three things. Because if sine's positive, cosecant's positive. This is just the reciprocal. Negative 2 flipped over is negative 1/2. If something's freaking negative, it's so just damn reciprocal. So we're only talking sine, cosine, and tangent here. So what we're going to say is that in the first quadrant, all of them are positive. In the second quadrant, only sine is positive. Only sine. Cosine and tangent are both negative. then we say only tangent is positive in the third quadrant. So this is our first, second, third, wow, and fourth quadrants. And then I think you can probably figure it out that it's going to be cosine. It's always positive. Because cosine goes with x. Look, positive freaking x's. All of them are positive, and cosine are positive, and the x's. Sine goes with y. Isn't this where the positive y values are? So sine, and all of them in the first quadrant, because everything's freaking positive. And then tangent's the weird one, because everything's freaking negative in the third quadrant, right? X's and y's. But that's because you have a negative over a negative. You have the y over the x, which creates a positive. So there's your little game, ASTC. There's lots of different little acronyms. I can let you look them up. There's all students take calculus. I don't like that one very much because that's not true. That's not true at all. When you pass a calculus class, be very proud of yourself. A lot of people don't do that. Not a lot of students do that. One's more appropriate. All students take cash. That makes more sense, huh? There's also more that are derogatory towards people's profession and things like that. I had some buddies come up with some in some classes. This one's a little off-putting, but I preface it by the person being someone that watched after children. That was her job, and making sure that they stayed safe. So she came up with it with her mind all day long, thinking, well, they come up with something that's clean, that's going to stick to the brain. And she came back with all strangers take children. Whew, that one stuck with me. I don't know. But anyway, you can remember the ASTC. You got to think, she worked in a job that all day long. Like, stay away from the kids. It's my responsibility. So that's why that was on her mind. But ASTC, it's a helpful little thing. So when we want to figure out whether something is positive or negative in which quadrant, you can just look. Well, all right, enough babbling.